on chapter 22. It's basically magnetic field and magnetic force is very common to you guys because when you are young, you play with the magnet. Magnet classified as North Pole and South Pole. This is called North Pole and South Pole. And the North Pole and South Pole will creating magnetic field. So magnetic field start out from north and end up at the South Pole. So again, just like electrical charges have a law of electrical charges called Coulombs, right? Coulomb say the light charges repel and these unlike charges attract. So do the pole in magnetic field. The law of poles. The same side of pole, north and north, repel each other, and the south and south pole will repel each other as well. But when the north and south, then they will attract each other. So when this is occurring, the north pole and south pole between them creating a magnetic field. In the future, we will find out, especially in the later chapter, you will find out when there's an electrical field, there will be a magnetic field. They go together, in which case electromagnetic field. And we will learn that. So the law pole says the North Pole and North Pole repel, South Pole repel, and North Pole and South Pole will attract each other. So the next thing we do is related with the charges. What is the effect of the electrical charges? The effect of electrical charges is in magnetic field, we are creating force. That means if a magnetic field go this way, this is a magnetic field go this way. If electrical charges, in which case called Q, is moving in this direction. This direction, in which case, is perpendicular or with the angle. You can draw this way. In that cases, that's an angle. In here, have an angle theta. And if we say the V cross B, this is spelled out called cross. V cross B. Cross is different than multiplication. Cross involving sine theta. Okay, Q times B sine theta. Multiplication is Q V times B, but that's not it. It's related with the vector. That means if a charge moving in this velocity and magnetic field in this, then it creating a force perpendicular to the plane made out by the magnetic field and the velocity. So it goes this way. So you can using what we call the right-hand rule. Right-hand rule is something you write like this. V cross B, then it's perpendicular that way. And you can go this way. Again, it's right-hand rule. The form is go out this way. The B cross V and go out this way. So in the book is spelled out exactly using the hand-shaped version. This is B and this is a V, and then go direct perpendicular is considered as magnetic force. So this is the situation. So right away, after they discover this, they have another one to do is how about the electrical charges? When it moving, have a magnetic force pushed this way, then we figure out related with centripetal force. Then when we go in this direction and related with the centripetal force, then we can creating a charge moving circular in the magnetic field. This particular effect and experiment will be performed. And by doing this, we can using this design instrument, in which cases we call the mass spectrometer. That means we can using this method to find out the small charges, the mass of small charges. So one thing we like to know for sure, remember the unit of magnetic field is called 1 Newton second per Coulomb meter. It has a name. It's called 1 Tesla, 1 Tesla, or 1 T. T spelled out as Tesla. So that's the case. So then move on to the next section, in which case is related with our laboratory later on, section 22.3. This particular one is related motion of a charged particle in a magnetic field. Motion of a charged particle. And the charge we like to say Q. Q in a B field. So we do that. So let's figure that out. Suppose that there's electrical charges moving in this direction. And then in this, preferably draw in this diagram. So here is the velocity v. And the electrical magnetic field is perpendicular to the motion of the electrical charges. This is a Q. So basically, what we have is V go this way, and the magnetic field go into the board. So we are using what? We are using right-hand rule, V cross V, and go up. So by doing this, the magnetic force will go this direction, we have sub V. If we go this our way, it will creating a circle. Creating a circle. If this creating a circle have to be related to the centripetal force. If the magnetic force equal to centripetal force, then the path of it, the path of the charges will be a circle. So in order to satisfy this, these two forces should be equal. So in this case, then we have QVB, assuming it's in perpendicular situation, then we have QVB, and this is equal to the magnetic force, and centrifugal force equal mv squared divided by r. The r is the radius of the circle. So right here, we like to say is r. And because of this, then we can do a lot of things then. Then we have to say r is equal to mv squared divided by q